Okay, welcome dear students from all over the country and worldwide. It's mathematics, advanced mathematics, pre-form 5, and our topic is sets, and we are still in the first subtopic, which is introduction. And in this subtopic we have already discussed or learnt about the definition of a set, and also the methods or ways of representing a set. And we are just for reminding that a set which perform the common function, or a set is a collection of objects with a common purpose. That's what you can say a set. For instance, the collection of plates that can be considered as a set simply because the plates normally they are used for putting food on it, is it? But also you can say maybe the set of teacups, that can be also a set. And you have also seen previously that for instance we have the set of sofa set. There is a sofa set. That why? Because those sofas are normally used for sitting, so we can say that they perform the similar function. If that is the case and they are collected together, we can say that is a set. Now for today, let us proceed. It's all about the types of a set. Types of a set. The first type is an empty set. The first type is an empty set. We are saying that if there is a set containing non-elements, that is empty. That is empty set. That means there is nothing inside a set. That is what we say an empty set. Now, according to Advanced Mathematics book published by TIE, Tanzania Institute of Education, it has been published or written that a set which does not have any elements inside the curly brackets, if inside the curly bracket there is no element, that is an empty set, and normally is denoted by this symbol, this one, or we can say the empty set can be represented by this symbol. But if maybe that set has been deduced from the roster method or listing method, we can say it can be represented by the curly brackets with no elements. That is all about. Now, for you to understand it well, let us consider the following example. For instance, let's say set A contains three-sided rectangles. Three-sided rectangles. That means a set of rectangles which have three sides. Now, is it a real set? Does it exist? Do we have the rectangles with three sides? Here is the solution. Here is the solution below. Yes, I've tried to write it and to put some figures here. We can say that set A is empty. Why? Because the rectangles has four sides, not three sides, not C's, not three sides. So let me correct this word: three sides, not C's. Yeah. Okay. Why can we say that? Or why do I say that the set A is empty? Why? Because now let us see these rectangles here. These are the figures, so we call rectangles, and these rectangles have four sides. We can count it. This is the first side, second side, third side, and the fourth side. Now, because the rectangles has four sides, then we can say that we don't have a rectangle with three sides. So there is no such a set. There is no such an element. So the set A is empty. Yeah, that is the first example. Now let us continue with other examples. Here is example 1 or another example. Let's say set B contains numbers. Let A set B be the element of X. Set A contains the element of X. But what is X? X are all values from 7 up to 8. X are all values from 7 up to 8. But remember, X is an element of natural numbers. X is an element of natural numbers. Now let us discuss the answer of this one, so that we can now will be able to judge whether it is a empty set or not. Now, in order to answer this question, the student must understand the definition of natural numbers. The natural numbers, these are the counting numbers, like 1, 2, 3, 4, etc. But according to our condition given here, we need to find the numbers between 7 up to 8. The numbers between 7 up to 8 are 7.1, 7.2, 7.3, 7.4, 7.5, up to 7.9. Now, these decimal numbers are not natural numbers, because the natural numbers normally they are just counting numbers 1 up to etc. Therefore, we can say set B is an empty set, simply because there is no natural numbers between 7 and 8. Maybe if it could be, maybe it would be, let's say, 7 up to 9. Yes, there we can say there is a number between 7 up to 9, 7 and 9, there is 8. So if that was the case, we can say maybe that is not an empty set. But because it is 7 and 8, between 7 and 8, so this is an empty set again. Okay, let us come to another example. Yes. Okay. Another example is that given that K is equal to elements of X, set K is equal to the elements of X, such that those values of X ranges from negative 10 up to negative 1, while negative 10 and negative 1 are included. We are saying that they are included due to the use of these two inequalities. These inequalities means the numbers mentioned are included. And also to remind you, this is the method. This method of representing a set is so-called set builder notation. Set builder notation. We have learned about it. And the question is, find the natural numbers which belongs to X, while X is an element of natural numbers from this set. So we are going to list the numbers. Can list the numbers? We can use the roster method to list the all elements found between negative 10 up to negative 1. After that, we can define those numbers by determine that whether they are natural or not. So stay there and see how to write it. Now here is the solution of example 2. So this is the solution. Okay, now let us see the solution of example 2. I have tried to define or to list all the numbers between negative 10 and negative 1, that the numbers are negative 10, negative 9, negative 8, up to negative 1. But we know that from one concept that the natural numbers, as I have said, these are counting numbers, which is they start from 1 up to infinity, up to etc. That is up to infinity. Therefore, because these negative numbers are not counting numbers, we can say that now set K is an empty set. Set K is an empty set. And Why do I use this sign here, the empty curly bracket? It's because the elements in set K are listed. That is because of this one approach. That's why I put this the empty curly brackets. So let me give you a quiz so that you can try to do it by yourself, right, dear students? Okay, dear students, here are 2 questions. You can perform it by yourself, and you can leave your answers in the comment section, or you can use this WhatsApp number and to show me your answers. So I encourage you to try to solve these 2 questions, and after that, for this time, let us continue with another type of a set, which is equal set. Okay, another type of a set is called the equal sets, but it's like a condition that 2 sets are said to be equal if they have the same number of elements. That means the number of members in a set are the same or are equal, but these elements must be alike. That means they must be similar. They must be what? Similar in every aspect. For instance, let's say there is a class A with the students like Jane, Juma, Joyce, and James. See? But also there is another class with the same students, that is Jane, Joyce, Juma, and James. Now, because the same students, the students with the similar names and the same number, they are in different 2 classes. We can say that the 2 classes are equal, or the 2 sets are equal, simply because the number of elements are equal, and also the type of elements inside the set are alike. Is it clear? Let us see a simple example below. According to this example here, it has shown that it is given that set A have the elements 1, 2, 3, 5, 4. If we count the number of elements inside or belongs to set A, the number of elements, there are 5. They are what? 5. But for set B, the elements are 3, 1, 4, 2, 5. Can you note something, that the elements are alike, but the difference is just the arrangement. Here they are arranged from we call it ascending order, while this is random arrangement. But the elements are alike, but also even the number of elements in set B is 5. Therefore, we can say sets A and B are equal. Simply because the number of elements of set A is 5. Also, the number of elements in set B is 5. These numbers are the same. And the elements 1, 2, 3, 4, and 5, they are both found in both sets, or belong to both set A and set B. Due to this condition, we can conclude by saying that set A and set B are equal sets. Yes. Let us see another example. Okay. Example 1 for second type of a set. That if set Q comprises elements named Arusha, Mbeya, and Tanga, Here, dear student, you must understand what are these. Or you can say what is the common name for these elements. Arusha, Mbeya, and Tanga. While set P comprises or includes the elements like Temeke, Hai, and Malinyi. Now the question is, are the two sets equal? Are they equal? In order to judge or to say that they are equal, we have to consider two conditions. The first one is the number of elements must be equal. Now, let us check how many elements are there in set Q. There are 3. And what about in set P? They are also 3. So the first condition satisfies that both sets have 3 elements. But don't end there and make conclusion. Consider the second condition, that also these elements must be alike. Now let's see here. This is Arusha, Mbeya, and Tanga, but so much quite different from those elements in set P, which are Temeke, Hai, and Malinyi. That is, therefore, we can say these elements are not alike. If that is the case, one condition does not satisfied. Finally, we can say set Q is not equal to set P. So these are not equal sets. They are unequal sets. Yes. Let me write it down. For better understanding of the equal sets, we need to learn simultaneously with unequal sets. So we must understand also the other sides of equal sets, which is an unequal set. For instance, according to this example, we have seen that since the number of elements of set Q and P are equal, so we have said that the first condition or one condition satisfied, but the elements are not similar. If that is the case, we can finalize by saying that Q is not equal. This sign means not equal. Set Q is not equal to set P. These are called unlike sets. Unlike what? Sets. While the previous example is called like sets. So let us end for today here. I will leave you with, I will give you some questions, and you are going to try it by yourself. And as I have said, I can mark by just having communication with you. You can use my WhatsApp number, or you can write your answers in the comment section, and then I will reply to you as early as possible. Okay, here is an exercise for you. You can copy those questions and do it by yourself. Yes, but don't hesitate to contact with me whenever you face some challenges. But also, I advise you to find the Advanced Mathematics book for Form 5, so that you can have much more practice at home by yourself. So, thank you so much.